Okay, section 4.2 begins with polynomial long division. And before we get into that, let's go back and review the terms really quick. They might come in handy. Plus, I'll do an example of long division with just numbers, just to show the similarities between it and polynomial long division. So let's start with some terms. So a normal fraction is actually a division problem, and we normally refer to the numerator and the denominator, but we're talking about division. The dividend is on top and the divisor is down below. Okay, sometimes you'll see it like that. Often you might see it written this way. So dividend divided by divisor, or dividend divided by divisor. What we're going to want to do when we do long division with polynomials, and also in the next example with numbers, is we need to take either one of these problems and convert it to this format. The divisor divided into the dividend. So we're going to want to work with that form there. Also, when we're all finished, the answer here is referred to as a quotient. And when we're all done doing our work, we may or may not get a remainder. We'll see that in a minute. So that's how it looks. Okay, so let's work through a problem with normal numbers first, and then I'll do a polynomial example, and you'll see how similar it is. So let's try this one. If that's the problem we're given, and again, if that's a polynomial and that's a polynomial, it's not going to really be that much different. We want to convert to this form here. So we divide the top number by the bottom number. And then basically this is how it works when you're dividing numbers or polys. You look at the number out here. This is your leading term. And we're starting off here working from left to right. So our leader here is 2, but that's too small. So then we go to 21. And we stop and we say, well, what do I have to multiply 20 by to equal 21? Well, it won't equal, but 1 is as close as we can get. So 1 times 20, multiply these together. Okay, then you subtract. 21 minus 20 is 1. Bringing down the next number, 13. 20 times what equals 13? 20 times 0, that's as close as we can get. So 20 times 0 is 0, so there's nothing to subtract there. So we'll bring down the next number. And once again, 20 times what equals 137? We can get to 6, that's close. 6 times all of this is 120. Subtract. Nothing left to bring down, so this is our remainder. And of course, this was our quotient. Now, how do we write the answer? Well, there's 2 ways. Sometimes I'll let you get by with this, 106, and little r meaning remainder, 17. But the problem with that is, if you don't have this, you're missing some information about that 17. So the way you generally write it is quotient plus, and since it's all numbers, we don't need the plus sign there, remainder over divisor. So we write our answer like that. No different from writing something like 1.5, let's say. And if you were listening, the way you say that is 1.5. So this is actually 1 plus a half. But again, when numbers and fractions are together, the plus sign is assumed, so we don't write it like that. But keep that in mind, because when we're dividing polynomials and there's a remainder, we will need to use a plus sign because it's not a number next to a fraction. All right, so let's go to a polynomial. Let's take this. And let's divide that by this number, this polynomial here. Okay, two things to note when we're going from this format to this format. Number one, the polynomials have to be in standard order. That means the degrees are going down as you move from left to right, and these are in that order. Number two, any missing powers you have to zero fill. For example, here we're missing an x, I have an x squared, I don't have an x term, and then a 5. So when I'm setting this up, what I'm going to want to do is this. X squared plus 0x plus 5. We need placeholder there. And we're going to divide that into this one. I have x4 plus 2x3 Now I'm missing an x squared here, so I'm going to have to add in 0x squareds again as a placeholder, minus 8x minus 16. So now we're ready to start dividing, and we do exactly what we did above. This is your leading term here. Leading terms are always the left-hand term as you're working. This will remain the leading term throughout the entire process. However, the leading term here is going to start here, and then it's going to keep moving to the right as we're working through the problem. And the same thing. Here we looked at 20 and this leading 21 and tried to figure out what you multiplied 20 by. Same thing here. If I have an x squared here, and I'm trying to get an x4, what do I multiply this by? Well, x squared, right? So that's what I want to put here. So that goes here. Same thing, 1 times 20 equaled that. So now we're going to say x squared times all of this. X squared times x squared, x4. X squared times 0x, so we're going to have 0x cubes here. You could do that, or you could just leave a space. And then x squared times plus 5 plus 5x squared. Draw a line. Just like here, we're going to subtract. x4 minus x4 is 0, and that's what you want. That leading term needs to drop out so we can keep moving to the right. 2 minus 0 is just 2, so have 2x cubes. 0 minus 5 is minus 5x squareds. And just like here, what do? Bring down the next term. Minus 8x. Leading term, here's our new leading term. So if I have x squared, what do I need to multiply to get 2x cubed? Well, I'm going to need a 2 and an x, right? That would be 2x cubed. So I want 2x here plus 2x. Again, multiply this by all of this. 2x times x squared. 2x cubed. These need to match, and they do. 2 times 0 is 0, but those would have been x squared, so let's just say 0x squareds. And then finally, 2 times 5 is 10x. Draw a line, subtract. 2 minus 2 is 0. That's what we want. That leading term needs to drop out or you've done something wrong. Minus 5 and 0, that's just minus 5, x squareds. And then minus 8 minus 10, that's minus 18 x's. Bring down the next term, minus 16. New leading term. Okay, again, my leading term here is x squared. The question is x squared times what equals minus 5x squared? Well, we would just have to multiply this by a minus 5, right? So we put a minus 5 here. Multiply minus 5 by all of this. Minus 5 times x squared. Again, that matches, that's good. 5 times 0 is just 0 x's here. Doesn't matter if you put plus or minus, it's 0, so nothing's going to happen. Minus 5 times plus 5, that's minus 25. All right. Minus 5 minus a minus 5, that's 0, because that would become a plus. Minus 18x. And here we got minus 16 minus a minus 25, so that would be 25 minus 16, that would be plus 19. Nothing else to bring down. That's your remainder right there. That's your quotient right there. How do we write the answer? Like this, but with a plus sign. So the answer is x squared plus 2x minus 5 plus remainder over the divisor. And we don't need the 0 fill in there anymore. So there it is. Okay, the next part of 4.2, we're going to talk about an easier way to divide polynomials called synthetic division. But there's a problem. It won't work here. Synthetic division only works when the divisor is linear. And if you remember, the definition of linear was ax plus b. The key is right here. The exponent on x has to be 1. We had a 2 here, so you can't use synthetic division here. When you have nonlinear divisors, you have to use long division. Okay, so we'll move on to the next section, and we'll see how linear or synthetic division works.